Hi folks, this video is about naming forces and how to find the resultant force. So first off, what are forces? Well, the very simple way to describe a force is very simply it's a push or a pull, and the easiest way to measure it is with a Newton meter, that sort of spring scale thing. Now we show forces are acting on a body by drawing diagrams like this with the arrows. The longer the arrow, the greater the force. Now forces have names, you need to learn off these names. The force that acts down on all bodies on the planet is called the weight, and the force which comes from any engine is called thrust. Now the force which counters weight on a surface, so like the one I'm standing on at the moment, that's called the reaction force. And if this car is travelling through, say for instance, an atmosphere, well then it will have drag, it's a frictional force. If we consider a boat, again, the boat has got a force down called weight, and it's got a force up, which counters the weight, which is called the upthrust. A quick note on upthrust and what it is. If I've got a Newton spring scale, and I'm using that to measure the weight of this particular blob, and it says 1 Newton, if I want to measure the upthrust, I can use a setup like this. So what I have is I've got an overflow can, which is full up to the brim with water, and if any water spills out in this, it goes into a little tray, and the tray is on a weight meter, or a force meter. Now what I do is I take the blob and I put it into the water, and what happens is, well, some of the water gets displaced. Displaced is the language we use, and what that means is it goes in here. And what happens is, the reading on the Newton meter goes down. Things appear to be lighter when they're immersed in water. Say for instance it was at 1 Newton, if it goes down to 0.7 of a Newton, well, what that means is, that would mean that the upthrust must be equal to, the force up on the blob must be 0.3 of a Newton. What you will find if you do this experiment is that the force on the force meter down here is also 0.3 of a Newton. So the way you find out the size of the upthrust is it's equal to the weight of the fluid displaced. So this much fluid has been displaced, the weight of that fluid is 0.3 of a Newton, and that is equal to the upthrust on the ball. Okay, so we need to talk about, again, if I've got a blob, that blob is on the end of a string, and the force down is still called the weight, but what is countering the weight in this situation? We call that force in strings tension. So anything, a string, a spring, the force that they can exert on something is called the tension. If I've got someone on a swing, you often see diagrams like this. So this person has got a weight, and you see the tension in this particular rope and this rope is half of his weight. If I come along now and I, say for instance, cut that rope there, what will happen is the tension in the other side of the rope will have to double, or else he will fall down. So that's tension in ropes. Now, last thing you need to be able to do is you need to be able to look at one of these diagrams which have got numbers on it, and you need to be able to find the resultant force. The resultant force is the one force which could replace all the forces on the body, and the body would act in the same way. So let's have a look. We've got 5,000 newtons acting down and 5,000 newtons acting up, so there's no forces overall acting in the up or down direction. But I've got 8,000 newtons acting this way. I've got a drag force, because it's going through the air, of 3,000 newtons, and I've got a frictional force at the wheels of 1,000 newtons. So altogether, they up to a frictional force of, altogether the frictional force backwards is 4,000 newtons. Very often in exams, they won't bother telling you where these forces are acting. They'll just put in one force like this. What is the resultant force in the car? Well, it's 8,000 going this way, 4,000 going this way, so 8,000 minus 4,000 equals 4,000 newtons, and force is a vector, so what is the direction? The direction is this way. 4,000 newtons that way is the direction of the resultant force. And that is the end of the lesson.